Session 9, Geomorphology, Stratigraphy, Paleontology and Tectonics. The chairperson of this session is Professor Dr. Peter Haproff.
Hello.
Chairperson is Dr. Kamalakanta Acharya and reporter is Alina Kagi. I would like to Dr. Peter to conduct the session.
Okay, great. Thank you all for coming. We have 3 talks. We had several presenters that could not present. So, yeah, as mentioned, my name is Peter Haproff. The co-chairperson for this session is Dr. Kamala Acharya here, and then our rapporteur is Alina Karki over here. Our first talk here is going to be Pradeep Devkota. Is Pradeep here?
Yes, I'm here.
Oh, there you are. Great, awesome. So his talk is titled Identification of Fractured Cross-Structure Zone in Chandragiri, Marku area, Lesser Himalaya, Central Nepal. And those who are presenting, I will give a 1-minute warning. I'll just go like this at 11 minutes, just to let you know, and then we'll do a Q&A session. Sounds good? Great. All right.
Yeah, thanks. I'm Pradeep Devkota in front of you here to present my work on identification of fractured cross-structure zone in Chandragiri, Marku area, Lesser Himalaya, Central Nepal. I want to begin my presentations. Geology of Nepal Himalaya. Himalaya is dominated by numbers of laterally continuous range parallel faults formed by the ongoing continent collisions. However, there are several transverse topographic breaks in the Himalaya, which is known as the lineament structure, and most of the lineament structure in the previous was done through the photogrammetric study. And today I am focusing with the verification of that previous study in the central Nepal. Initially in the Marku area, another 1986 done a photogrammetric study in the Kulekhani watershed, and he identified several linear structures. We can see that in the top here, this is the north direction, and he identified several linear structures trending towards the northeast directions. This is the Kulekhani dam. We can see here in the red line. After that, Dasgupta in 1987 also studied the linear features in the Himalayan regions through the same photogrammetric study, and he identified several linear features which was verified as a crossfall later during the field observations. And we can see that in the central Nepal there is a Juri fall and Thapli fall in the northwest part of the Kathmandu Valley. And below the Kathmandu Valley, we can also see the Bigfeli and Kathmandu lineaments. In the eastern regions, we can see a Gauri-Sakhar lineament over here, and Matihari Abresh lineament in eastern Nepal. And in 2018, Mukhul also identified the Giz fault in India, and in yesterday's session, where he also mentioned that a Bekar fault zone in the eastern Nepal, which is as a cross fault in the Himalayan region. In central Nepal, lots of similar transverse lineaments were previously reported by Dasgupta Ho, and there is this suggests that there is a strong possibility of cross fault in central Nepal. Ho 1998 also identifies similar linear features in the north of the Kathmandu Valley, and he named as a Langdang Depression, which is located in the north of the Kathmandu Valley. In recent time, Godin and Harris 2014 studied the whole linear structures in the Himalaya, and he identified that this linear feature is as a result of basement cross stripe valley, and this is the western edge of the Mundir Sarsari is present in the Indian crater. Because of this ridge, the linear features are obtained in central Nepal. Similarly, Sterling also identifies several linear structures in the central Nepal in Kulekhani area. This is the Kulekhani dam, and we can see this black line over here trending towards the northeast direction in central Nepal. And this is the colorful map made by the DMZ. This is the modified version of the Sterling map. We can also see some of the linear structures, some of the offsets over here, which was previously identified by the Sterling in 1980. Okay, this linear structure also limits the seismicity and ram geometry in the central previously studied by Rajul 2013, Harvard 2021, and there is not a comprehensive field-based research work in this central Nepal here in Kathmandu Valley, and my work is focused in the southern part of the Kathmandu Valley in Kulekhani watershed area. And we can see this is the aerial Google image of the southern section of the Kathmandu Valley. Here is the Kulekhani Dam, and we can clearly see that some of the linear structure is here. And my aim to do this research is to identify, to verify these linear features in the field. And here are the linear structures that we focus during the field work. And this is the geological information of my study area. We can see my study area is located in the Kathmandu complex rock of Central Nepal. This is map from the DMC, and this is map from 2015. This is the published maps and figures. After compiling all these maps and figures, and I do the field verification. During the field verification, I do detailed field mapping, systematic sampling, thin section preparation, microstructure analysis, and final discussion. Well, I am not the expert in remote sensing, but I learned from the online, and this is just a trial method. Basically, this remote sensing analysis is done for the mineral perspective mapping or mineral mapping, and I use here. We notice that some of the linear structures that are striking in the north-south direction in Kulekhani watershed. We can see here in the red line. These are the some features that are updated. This is running from nearby from Kulekhani Dam, and here Sisnari Valley also. Prepare the dam image and inset maps in Kulekhani watershed, and from that map with different angles, some of the linear structures over here. I am not sure these structures as a cross-structure linear features, but during the compiling all these 4 maps and the previously found linear structure, and I do the verification. Linear density are in Chakel area, here in Kalinge and Panjang area. And these all these structures are previously identified in the Google Earth images and remote sensing images. This is area, this software and signal formations were studied, and some of the systematic sampling done over here. And this is my geological map, and this cross section in 1:25,000 scales. And in the geological map, we can see that some of the offsets in the this is the Kulekhani. This extension is break over here, and some of the also offsets here in the limestones over here in the Matatirtha area, and we can also connect this whole offset section later also. And from the during the field, we identify several brittle deformations in the area. This figure is, you can see, this is the fault line which is trending towards the northeast direction. It is located from this section along the Kulekhani highway, and another is along the Kulekhani river section from Kulekhani to Sisnari. We can also see some of the origin and some of the other deformations, brittle deformations reported from the field. These are not the normal falling, but they are associated with the Kulekhani fault, one of the major fault in the Kulekhani watershed area. This fault runs parallel to the Kulekhani valley, and we can also see some of the brittle deformations over here. Along that brittle deformation, some of the ductile deformation also reported in the field as this is different types of faults in the area. Some of the spurious folding here. And these are also some of the faults that are reported from the tissue formation in phyllite and metasandstones. They are brittle faults and some folding over here. And one of the interesting is that in the Kulekhani watershed regions, this is along the Kulekhani to Sisnari highway. This side goes to the Sisnari, and you can see that 2 major syncline and anticline over here, and this all are trending towards the northeast direction. Maybe this is associated during the brittle deformations. Rocks and through from the granitic samples, and these photomicrographs were taken at our CDG lab, and I have used some microstructural analysis which on the reference of Hills and Tulis, and some from Pascal and Trout. This is the sample location map where I collected different samples, majority of samples from these sections. We studied the microstructure of the quartz grains, and we found that some of the quartz that exhibit the higher strength along this section. There are some GBR here over in this section in the quartz regions. Actually, this sample from the Chandagiri, marginal between Chandagiri limestone and the Chitlan formations. And one of the, you can see some of the quartz grain GBM and GBR over here in the Kirvanjang area, and other microstructures are associated in these regions are GBM over here in this Kulekhani cyst over here. We can see that GBM microstructure in the quartz grain present in the study area, which is not a single linear structure that we observe in the field. This is I call as zipper-like linear features present in Songlagiri Marco area, perfectly filled with the Kathmandu lineament identified by Coordinate Harris in 2014. Major lineaments, mineral lineations and shear planes were northeast and southeast direction, and the quartz grain dynamic recrystallization is high in this section. We previously seen our photographs. Zone of faults in the field during the field verification. Geological map around the fault zone reveals several offsets. We can clearly see in the contact between here Kulekhani formation and Marco formation, and distant formation. Also, some of the offsets over here. The microstructure analysis samples show the localized high amount of strength along this section, and the field range observation includes north-south striking belts of valley parallel faults and shear zones. Also clearly indicate some of the linear structures are present down here. And all the evidence strongly suggests that the presence of cross-fault in Songlagiri Marco area at the central Nepal. And finally, some recommendation for the future role. To verify this, this is my thesis area, this is my research area, but I have traveled down here and I have some field visit over here. The further detailed study is necessary to verify the northern and southern extension of this crossfall in central Nepal. Aerial photography, remote sensing data, fluvial gradient, and geodesic data, seismic data, which should be used for further verifications. And radiometric data is necessary pending this. And this was all. Thank you so much.
These fault scarps expressed, are they bedrock fault scarps or are they in quaternary strata? Is there any evidence of quaternary rocks that are cut by some of these?
We cannot find a clear offset in the quaternary sequence, but most of the rivers valley runs parallel through the middle of the quaternary sections. Quaternary deposits. Till now. Yeah.
Great, thank you very much. Right, great talk.
Now, the second presentation of this session is
Petromagnetic.
petromagnetic characteristics of proper sandstone laminae within the middle shivaliks of Amleganj area, Nepal. The paper is written by Kamar Gautam, Naran Paudel, Sudarshan Bhandari, Baburam Gewali, and Tayakasi Kartu. And the presenter is Baburam Gewali. So I would like to invite Baburam Gewali. And this 12-minute time is yours. Then we will discuss.
At that time, what we were doing was with the help of handheld magnetic surface meter, we went to various lithological sections and then measured the susceptibility for the magnetic minerals, which is useful to differentiate different lithology. We carried out the same study for lesser Himalayan rocks as well as the shivaliks, and this one comes from the shivalik section in Amleganj. So the talk is divided into 4 sections, that is geology of the study area and dynamic susceptibility profile, followed by mineralogy and petrography, rock magnetic data, and finally summary. So the slide shows on the left bottom, we can see the generalized geological map with the location in the square box, and then the shivalik location, and the geology of the shivalik area, which falls within the Heterodapokia area. Basically, the formation falls within the middle shivalik range, where the main rock that we studied was, or the sediments we carried out the study, falls within the sandstone mudstone alteration with peculiar purple line. So, when we were doing the study, and followed by the Google Earth image of the outcrop, which is here, the map is towards south facing elevation, and this falls on the right side of the bucket. These are the study sites that we sampled, AM1 to AM5 on the outcrop that we studied.
So here we did this. So this was the sampling with the hand drill in the sandstone monsoon operation, and this is the purple laminate that was found within the core sandstone, and this is the planar section of the same purple laminate. And as you can see that the color is representative of purple color, very good representation in color. What was different in that layer? So during the study, magnetic sensitivity, as we can see that it represents the fine, in fine the sensitivity higher in some cases, and in coarser ones it's low. So the cycle was going on in that trend. At AM3 and in between AM4, what we found is that the susceptibility increased significantly. What was the cause? And when we did the spot reading for every 5 centimeter, we found that yes, this was higher in thin 2 mm, somewhere around 2 mm this magnetic layer, what we are looking at here. And these are the layers that is represented purple laminate. First of all, when we found this layer, the first speculation was that the origin must come from the volcanic deposit or volcanic ash deposit. So we were happy, okay, because those are recorded in Pakistan, Kutwa Basin, and also in Indian Shivaliks, I think somewhere in Himachal. And so the first idea was to carry out the mineralogical study. While doing the mineralogical study, what we found is that the layer is thick for the purple laminate comes from the almandite or prominent dominant mineral is present there. And then the rise in magnetic susceptibility is due to the magnetite and hematite. That's what is shown from the X-ray diffraction. After this, okay, in X-ray we were not able to identify the glassy minerals or the glass minerals that we have to find in volcanic ash. So the second target was to carry out the work with thin sections, the glass that we were looking for, to say that okay, this comes from the ash. No, again in the thin section, what you can see that this purple laminate is finer in size than the host coarser sandstone, and it's rich in hematite, magnetite, opaque minerals which are quite similar to hematite, and others like garnet, those are present here. And this is the cross nickels and open nickels for the same purple laminate. For the host sandstone, yes, in this one also we have a little bit of hematite, but less in quantity than the purple laminate. And a few garnet are present also in the host sandstone, which are a bit coarser, and various other minerals such as biotite, hornblende, orthopyroxene, and other minerals have been identified. And as well as for the sand and pepper sandstone in the matrix and also the coarser one, what we found is that okay, here also garnet is present, there is a bit of hematite like opaques, and hornblende, kyanite, which comes from the metamorphic terrain and product. So this concludes that okay, there is no glass mineral to say that it comes from the volcano. So finally, why there is a rise? So remnant magnetization study was carried out, and in this one also, along different studies, AM1 to AM5, especially in AM3, what you can see is that it is rich in magnetite. That's what the remnant magnetization gives. And similarly with remnant susceptibility curve also give the prominent idea that okay, magnetite mineral is high in population in this purple layer, specific purple layer. Then the magnetic heavy study was carried out, and in this one what we see that okay, most of the degree of anisotropy is quite similar with the other sections of the Mediterranean, Pinacola and Thermal sections. with only 2 specimens showing anomalous characterization. Similarly, in the ellipsoid shape also predominantly oblate, and only 4 with the prolate shape. Similar with the Tinamula and canal section that have been studied earlier. So after that, as not only the magnetic susceptibility is important, but also the anisotropy is important. So with the anisotropy of magnetic susceptibility directions, the first one was whether there is a difference in between the bedding plane and magnetic mineral foliation is different or quite similar, and the result shows that they are parallel and there is not so many changes with the primary equational factor. But in terms of magnetic mineral lineation, we found that the minerals are related to east-west orientation, which is quite parallel to the fourth accident. First equation, and they give the direction of the compression as a tectonic or secondary fabric for the as terms of the magnetic fabric. Okay, finally, where are we in terms of geological time? As the section is quite similar to the Americans, is quite similar to the formation, is quite similar or within the same age range as that of the Vinayakula section in Vinayakula area, as well as British Valley from the Karnataka. So with that, the first speculation was 8 to 10 or 8 to 11 million years of age, and in this one we were unlucky. Based on the correlation with the other sections, we speculated that okay, the reverse polarity cone must come from C4R polarity, and the age, exact age for is taken from James Cook geological time scale, and the speculated age or the calculated age is 8.8 to 8.1 million years. So at this time period, yes, there are multiple events going on, just like the volcanic ash deposits in pretty for the rich garnet layer or high magnetic susceptibility in the purple layer where it comes from. So first one possible provenance source what we have speculated is the Mahabharata crystalline. The source should come from, the minerals should come from the Mahabharata crystalline or few big group within the lesser Himalayan zone or the high crystalline from the Kathmandu Nepal. And it is just, and also red faces, kyanite, right, as well as many sections with garnet deposits. And the possible mechanism is episodic MCT MG, that is Mahabharata thrust reactivation around 9 to 8 MA, and the exhumation, mineralization, and enhanced erosion with subsequent transportation of the eroded material by rivers and deposition into the proximal and fallen basin soil. So, as this is the steady area, and in red color we have the Mahabharata thrust or MCT and the MCT. So, if we assume that the source comes from here, it is not so far, so it fits with the tectonic activity or the reactivation magnetic polarity. So, what are the major findings? Geological observation serves as an effective mapping and correlation tool, which is also shown in the lithostratigraphy separation with magnetic susceptibility, contrast interest, estimation of sediment intervals of different scales, mm scale laminae, few meter thick beds with different grain size. Upward finding, sand and clay pattern that can be done. Compared to the sand and pepper, salt and pepper sandstone layer, the purple laminate poses dense mineral on the record and magnetic IQ anomalous. The reverse polarity cone C4R, that is 8.8 to 8.1 MA, and magnetic fabric shows primary deposition foliation and secondary tectonic lineation as in other second minerals are likely to offer useful for determining the provenance in the Himalayan. With that, I would like to thank Dr. Prakash Gulab for field that time, and this is the field survey team.
Your presentation is so impressive. Thank you very much for this very scientific presentation. Actually, I want to just ask with you that to analyze the province and many things.
Yes.
Where are such a type of other studies in the Himalayas that your study valid or not valid with other sections of the Shivalik range?
In terms of when we use the magnetic susceptibility, yes, one of the study I think was carried out in 2008 and published in Nepal Geological Society Journal in 2011 I think, which shows the magnetic susceptibility, use of magnetic susceptibility.
There was the magnetic susceptibility
Yes.
for lesser Himalayas.
Yes, that one was for the lesser Himalaya. And in terms of magnetic susceptibility, we have been using it for Shivaliks also. But in case of Shivalik, we were more prone to show the ages for the Shivaliks with the help of magnetic susceptibility and remnant magnetic susceptibility. But in this case, because our study was focused more on the purple laminae, which showed the higher magnetic susceptibility, that is, the composition has more magnetic minerals than in the other the host lamina. So, and the first speculation, as I said earlier, that it was quite similar to the age frame, or the geological area was quite similar with the volcanic ash deposit from Deccan that has been published in for the Pakistan section, and also for some sections in Himalaya, where they have shown the sources for higher magnetic susceptibility as volcanics. And it has also been done in various other sections also. But in our case, as we did the thin section analysis and also the X-ray refractive study with the for minerals, we were unable to find the glassy minerals. Then
This X-ray analysis was carried out from
In
limestone
Japan.
samples?
no, within the same layer, the purple lamina. It was for the purple lamina because that was the lamina where we have the higher susceptibility. And the first speculation was also because the color is also purple, very faint purple, not so. In some it is quite dark, but in some section it is quite faint. So, and it quite resemble with the volcanics. Quite similar with the tuba also, which is quite younger in Pleistocene. So that one was the case, but unfortunately we are unable to find that one. And as the susceptibility also with few papers. So with that we did the provenance study after that.
Thank you, Babu. This time for one quick question, and which I request Babu for the quick reply also.
Yeah, sure.
The presidency was excellent. The sandstone layer as well as the mudstone layer. Right? So my simple query is that why did we carry out all those study in that particular one thing you are clear that the magnetic susceptibility was a bit high in that purple area. But do you think we could conduct such that study in other layers as well? There is similar type of mineral assemblage in between the sandstone layer and the purple layer.
Yes, you can use magnetic susceptibility to differentiate between the layers with different magnetic susceptibility data. But in our case, when we studied that one, yes, this is the section where we have the clear picture, and the laminae was, and because this comes from a little bit of softer kind of, the lithification is not so hard. Similar kind of laminae has been identified in Amelia section also, but because there is quite hard lithology present there, so it is quite difficult to carry out the same mineralogical composition separation study. But yes, susceptibility, yes, you can carry out. Again, to find out the spike or rise, that is more important. To speculate whether to form analysis further or not.
Is by Rashmi Acharya and Dr. Kavi Raj Paidyal. And the title of the talk is Geological Mapping and Structural Analysis of the Kathmandu Nepal and Noakhot Group Interface, northwest of Kathmandu, central Nepal. Please.
Thank you, sir. It is a great honor to be here at the 11th Geological Congress, having opportunity to present my research. It's me, Rosmi Acharya. I would like to sincere gratitude to the organizers, Nepal Geological Society, for providing me with this platform to share my work. And today I will be presenting on geological mapping and structural analysis of the Kathmandu Nepal and Noakhot Group interface northwest of Kathmandu, central Nepal. Let's start with my presentation. Introduction, which is followed by objectives, methodology, result discussion, and the conclusion. And here is the introduction. Kathmandu Nepal, which is divided into the two groups. One is full topic group and another is synthetic group. The research area consists of two tectonic units. One Noakhot group and another is Kathmandu complex, which is separated by Mahabharat thrust. And this field of study enables the interpretation of detailed small scale data to regional scale geological structural patterns. And there is a lack of information on the type and position of the thrust, as well as an extensive understanding of the deformation history. This research aims to improve the consistency of the geological map and precisely indicate the position of the thrust fault. And here is the location map of the study area. The study area covers the most of the place of Noakhot district and some Kathmandu district of Bagmati province. And it covers the two topographic maps, one is Ranikawa and another is Sibapuri. It is about 65 km northwest part of the Kathmandu, which is accessible by Pasak-Lamu highway. And the objectives of the research: to study the meso and microstructures developed in the rocks, to interlink microstructures with the research structures in the region, to study the metamorphism and deformation history of the area. And this is the generalized columnar section of my study area. In my study area, two rock units. One is Noakhot group and another is Kathmandu complex. Benigar slate is the oldest unit of my study area. And the lithostratigraphy of my study area are shown in figure. Grey graphite consists of the Benigar slate, which consists of fine to medium grain into medium bedded phyllite intercalated with the slate. And this photograph shows the grey amphibolite, which is found in Roban formation and consists of phyllite, garnet, schist, amphibolite, and quartzite band in upper portion of the study area. This photograph shows the garnetiferous schist of the Rodua formation. In this formation, quartzite band is also found in upper portion. In my study area, most of three different gneisses: again gneiss, migmatite gneiss, and the calcilicate gneiss. And this is the migmatite gneiss, which appears to folded vein or like thematic fold, consists of quartz, feldspar, and biotite. And this photograph shows the coarse grained, highly foliated again gneisses, which is elongated or eye-length shape. And this photograph shows the interbanding of calcilicate gneiss with the marble. And this photograph shows the highly weathered fracture pegmatite. And this photograph shows grey metasandstone of the crystal formation. And Soprano formation, grey limestone. And finally, this photograph shows the highly weathered grey limestone of the Chandagiri limestone. And here is the geological map of my study area. In northern portion, upper Noakhot group is observed. In southern portion, Kathmandu complex was observed, and from Tajipur to Pokarithok area, Benigar slate, and from Pokarithok to Belkot area, one formation near the Belkot area, Mahabharat thrust. Over Pawa, a different kind of gneisses, migmatite gneiss, again gneiss, and the calcilicate gneiss is present. And from Over Pawa to Devithan, there is large amount of pegmatite is present. From Devithan to Hutkudoka, Stone formation is present from Mutkuloka to Sondagri limestone is observed, and in between and near the Zaikal Pawa, one seal form which dipping towards the center, and near the Ukla Pani, one antiform is observed to oil, dipping oil from the center. And here is the geological cross-section of the study area. In my study area, in northwest portion, upward backward group was observed, and in southern east portion, eastern formation and other Kathmandu complex form was observed. And here is the regional structures, Mahabharat thrust, which separates the low-grade northward group and high-grade Kathmandu complex, and located in the northern part of the area and lies between the Roban formation and Nadua formation. And this photograph shows the shearing, which shows the bitter breccia, wall breccia, and other center dipping towards the center, and one antiform, the southern and northern limbs of the antiform. This side photograph shows the axial fold, which trending north to south, which is irregular, convoluted shape. And below this photograph shows the lysine foliation near the Talotigao towards the Pakre. And sample RB14 shows both the dynamic and static recrystallization, which shows the triple junction and equigranular in shape. And another blue circle shows the dynamic recrystallization, which is irregular in shape. And another window and the bulging also shows the dynamic recrystallization. Window separates the other minerals or to near the minerals. Sample RB15 shows the pre-tectonic garnet. In this pre-tectonic garnet, and in this internal foliation is randomly oriented and top to the south trending. And RB13 also shows both the dynamic, and 79 also shows both the dynamic and static recrystallization. And pinning structure, which is also associated with the plating minerals and making the convoluted in shape. And other window bulging also shows the dynamic recrystallization. And this is the microstructural map from the thin section. In my study area, mostly GPR is found near the anti-zone, which form the slow state of recrystallization, which make the perfect shape. The deformation referred to as the D1 to D5, which is correlated with the Porel and Olita. And the left side photograph shows the myelite great mineral is found in Keystone formation, and fluoride is found in Sondagri limestone. And this table shows the three different phases, basis phases, epidote antibolite phases, and antibolite phases, and the four zone, fluoride zone, and myelite zone, garnet zone, and the slimlite zone. And similarly, different kind of minerals is also present: plagioclase, quartz, muscovite, and fluoride. And Keystone formation, Sopan formation, Sondagri limestone is rich in fluoride zone. Bengal slate is rich in myelite zone. Roban formation, Nadua formation, and Jurithum cisterni gneiss or gneiss zone is rich in garnet zone. And Jurithum cisterni, some part of and most of the part of Jurithum cisterni gneiss is in slimlite zone. And this is the metamorphic zonation map. In southern portion, Kunjoti group of Kathmandu complex reaching fluoride zone. In northern portion, Bengal slate reaching myelite zone, and in near the anti-zone reaching garnet zone, and in the center portion or most of the gneiss zone reaching slimlite. And this slide shows the discussion correlated with the stocking 19 and AMC 2021. In my study area, Bengal slate and the Roban formation was observed, and Kathmandu limestone is missing due to the displacement of Mahabharat thrust. And Mahabharat thrust has separates the Nadua formation from the Roban formation, and Nadua formation is correlated with both the DMC and correlated with the stocking 1980 and stocking and trial 1977, which was classified as a Kaljar formation by DMC. And banded gneiss was observed in my study area. Also, Roban marble is missing, and banded gneiss, which was classified is a Sivapuri gneiss by DMC. And similarly, Nematite gneiss is observed, which is classified as Oggen gneiss by DMC. And Oggen gneiss is observed, which is classified as a Sivapuri gneiss by DMC. And Pegmatite rock was observed, which is classified as a Sivapuri recognized by DMC, and similarly crystal formation, Sopan formation and Chandrakiri limestone is correlated with both the DMC and Stockling 1980 and Stockling and Patrai 1977. And here is the conclusion. The area consists of two tectonic groups, Upper Nuabu group and Kathmandu complex, which is separated by the Ante, and the position of Mahabharat thrust is located on the basis of lithology, metamorphism, structures and petrographic analysis. And petrographic analysis shows the structures such as bulging, recrystallization, and rain boundary migration shows the both dynamic and static recrystallization, and the temperature rises as one moves towards the Mahabharat thrust. And in the study area, important metamorphism and the retrograde metamorphism are observed, and the area has undergone a complex geological history within several phases of deformation. And here are some references. And at last, I would like to thank Dr. Kaviraj Paudel and Professor Dinesh Pathak sir and whole Central Department of Geology. Thank you.
Very interesting talk. Are there any questions? Any questions? I guess I can ask one question. Is there a very strong these rocks? Do you observe that? Is there a very strong mineral stretching lineation in addition to the foliation in these rocks?
Foliation.
Foliation, and probably lineation, I would think too. Great. No questions? Okay, thank you very much. Okay, so next we will have the poster coordinator and poster authors come up.
Thank you very much, sir. I think we will have very water command model for the distribution of token of appreciation. The session chair. Similarly, I like to call Dr. Kamala. Similarly, I like to call
This poster presentation is arranged because some of the oral presenters are absent today. So we are going to utilize this time by the presentation of poster presenters, and the total time for each presentation is 3 minutes. And here will not be the question and answers from the participants. For question answer, please visit our poster presenters outside because the posters are already there. And for this poster presentation, I am coordinator of this session, and we have 2 more members to conduct these sessions. Dr. Basanta Raj Adhikari, I request him to be here, and similarly Dr. Rama Mohan Pokhrel also to be here. So now we together run this poster session. Thank you. And now our presentation slides is uploading now here. So let's wait a few minutes to conduct this presentation.
And I'm the main geologist at Kodaria Limited. And as doing the geology, mine geology. So in this presentation, I am presenting what are the raw materials that are available in Nepal Himalaya and how my research is going. And the tiles in Nepal the tiles are very traditional and modern architect, and it is evaluating different processes regarding the different types of quality. In Nepal Himalaya, there is a different types of raw material that is used for the tiles production, and plastic raw material and flux raw material, inert materials, and collective components, essential raw materials for the production. And moving to raw materials, these raw materials are divided into plastic raw materials, and these are flux raw materials, inert raw materials, and collective components such as clay and kaolin is under the plastic raw materials, feldspar for flux raw materials, and silicon, sand, and glass for talc and dolomite for collective components. And here is the some types of what kinds of quality they are used for. That's for cohesion, used for plastic raw material, and iron efficiency, we use flux raw material. For mechanical efficiency, we use inert raw materials, and for dimensional efficiency, we use collective components. And these raw materials are available in different zones of Nepal Himalaya, such as for the clay and kaolin, we can solve visually, and the lesser Himalaya section. Whereas feldspar is available from granite, and gneiss of the Himalaya, which is a product of granite and gneiss. And for the silica sand and quartz, we can find out in lesser Himalayas such as Kathmandu, and for the tile dolomite and calcite, we can search in lesser Himalayas such type of like Harin dolomite and in molecular limestone. And by using this types of the raw material, we can finally reach our product.
Okay, please conclude.
Okay, sir. And these are the some types of raw materials that we available in Nepal Himalaya. And the parameters using for raw materials are their color, loss of emission, and silicate water erosion and moisture content. And in conclusion, that is the evident clay and silica and feldspar are available in Nepal Himalaya. And for further specific research, the specific flush materials may be needed to ensure and maybe they may our supply chain in industry. And at final, if please visit my poster at C, and for abstract, it is available in Journal of Nepal Geological Society abstract volume and special volume page number 21. Thank you.
Samyog Khanal, Geological Investigation of Thawang Jalgala section in Western Nepal. So Virendra, it is your turn.
Namaste, I'm Virendra Bosne, and my topic is Geological Investigation of Thawang Jalgala section in Western Nepal, and my poster is outside at poster number 9. Here I have done some books for my master's thesis. Here is the study, black line shows the study area of my thesis area. These are some photographs and outcrop, and this is a stratigraphic section of Lukum to Jaldala. And here is my conclusion.
Okay, conclude shortly. Okay, thank you, Virendra. And now the next turn, Asta Paudel, background noise analysis of Kokani seismic station.
So, good afternoon everyone. Thank you for being here. I'm Asta Paudel from Central Department of Geology, Dubai University. Let's get into the background noise. So background noise are the continuous low-level vibrations that are detected by the seismometers, which are very different from the earthquake, which are violent and sudden events. An importance of background noise analysis is that it allows the seismologist to detect the noise level variations for seismic monitoring and risk assessment. So the main objective of this research was to assess the station's performance and to analyze the variations of the background noises in different time, and also to determine the possible sources from the of the background noise, which are analyzed from the frequency. So first we have time series analysis, which shows the seismic noise level from the 2021 to 2024. This is from the 2021 and this is 2024. It shows the regular pattern of the high bands and the low bands, and a little anomalous band is also observed, maybe because of the increase of the activities near the seismic station. And also gained from this plot further of only 2021, a PPST plot is developed, which is plotted by the plotting of the 1,32,000 segments, which is pretty more. It shows the spatial distribution of the frequency. And here are the other significant results. Diurnal noise variation was seen, which is basically the noise level in the daytime and the night time. It can be seen that noise in the daytime is significantly higher than that of the night time. And while quantifying in this time, which is around the September of the 2024, we can see that there is about 88% reduction in the nighttime noise level than that of the daytime. Here, a seasonal variation is observed. In the greater frequency range, there doesn't exist any before monsoon and during monsoon noise levels. However, in the lesser frequency, about 5 to 10 decibel difference is observed.
Please conclude shortly.
And lastly, this is an interesting finding that we have seen during the data analysis. It is seen that it is a plot of 2025 February, and in only the February 14 there is a spike in this level. As we all know that Kakani station is pretty famous and it's a great picnic spot, hanging out spot. February 14 hike can easily be correlated into a Valentine's Day. So this was interesting finding. So thank you guys for being here.
Okay, thank you, Astha Paurel. I am not sure whether there is a Navina Timansina or not. Okay, Navina, is it your slide uploaded? Okay.
Hello everyone and namaste. So going to the introduction, all we know Kathmandu Valley is highly urbanized and it is very vulnerable to seismic hazard due to its geology and urbanization. So these are the stations we can see here. Okay, these are the stations we can see here. I have down in that boulevard. So the main objectives of our study is analyzing the main causes of the background noise in Kathmandu Valley and evaluating the seismic noise at different locations using data from Raspberry 640 and multi-seismometers and examining how background noise varies over the season and between the day and night. So going to the results and conclusions, noticeable fluctuation in seismic noise are observed over time with varying levels of displacement, as you can see here. This bright color shows that the noise is high, and in the daytime the noise is high, and in the night time the noise is low. The dark purple color shows that the noise is low. So going to this plot map, we can also see here the noise is high at the daytime and it's decreasing at the night time. So it could be due to the human activities pattern like traffic and industrial work and business operations could contribute to daily and weekly variations. Thank you. Thank you for being here.
Okay, thank you, Navina.
So next presenter, Ludovic. Are there?
Hello everyone and namaste. Thank you for being here today. So yeah, probably most of you know now there's been a scientific collaboration between France and Nepal for 47 years now. Yeah, the goal of the collaboration to record and understand and make some research about what's happening around us. And yeah, so on this poster, the poster's purpose is mainly to highlight what has been happening for these 47 years and how the work of all of the collaborators hand in hand has allowed us to today deploy 23 seismic stations, permanent 23 seismic stations, and to make this network like it is today. Just a few, also to highlight a few main events, as for example the upgrade from analogic to digital, and also the update of the data centers, because 47 years is a long time, and machines start to age in some cases, but yeah, it's an ongoing thing and it's working quite well, so that's kind of nice. So on the poster you'll find explanation on how do we maintain and organize the stations. So if you have some questions about this, please do come, and I'm sure that my colleagues and I will be very happy to explain to you how we've learned to install these things. So that's basically the idea of the poster, to just explain and open to what's happening in Nepal now in the Department of Mines and Geology. And also to thank everybody who's been helping for these 47 years, because that's many generations of people, and that's awesome. So yeah, that's a short glimpse of the network of today. So as you can see, it's covering quite a long area of Nepal. So if you have some kind of questions about that, please do come. As you can see, it's more of a technical and logistic explanations. If you want to know more about what has been produced in the recent flow, I would suggest you go and read the work of Loc Pigeaticali, Laurent Beninger, Theo Besson, and
Please conclude.
And that's it.
Thank you very much.
Bye.
And the next presenter is Kavita Pandey. Are you there?
I'm Kavita
Pandey, and I'm here to present on behalf of my team. The title of my presentation is, or the poster is, A Decade of GPS Monitoring in Nepal by Nepal Academy of Science and Technology. So it's been quite long time, more than a decade since we have been working in the field of GPS and GNSS, and basically the poster highlights what NAST has been doing over the past decade. We have been installing 11 GPS stations in the central part of Nepal. So the GPS sites are regularly being monitored. The data are being collected. We have, before installing the sites, we have considered some of the criteria, and also we have mentioned all the several criteria, and the stations can be seen in the video there. And there are various applications of the GPS stations which have been installed by NAST, and you could see various papers that has been published from the data of Nepal Academy of Science and Technology, basically using the GPS networking and all. And if you'd like to know about more, our team will be very much happy to explain about what Nepal Academy of Science and Technology has been doing over the decade. Our poster is in the poster number 8, stall number 8. So we'd be very happy to see you there, and definitely we will be answering all of your queries. So thank you so much.
Thank you very much. Next, Ramesh Gautam.
I'm Ramesh Gautam from Nepal Academy of Science and Technology, NAST. The title of my poster is Impact of Land Frequency on Geotechnical Properties of Study from Gonzales Data and System Data. I would like to invite all of you to visit my poster and give valuable feedback and suggestion. My poster is in poster number 12.
Thank you very much. So next, Navin Raj Joshi. Namaste everyone. I am Navin Raj Joshi. I am an engineer at the Department of Water Research and Irrigation. I am also serving as the president at Nepal Engineer Research Supervisory Board. My research title is Land Suitability Analysis for Agriculture, Surface and Lift Irrigation in Supervisory Province, Nepal. For introduction, why I conducted this study is global food demand is projected to be increased by 35 to 56% from 2010 to 2050. To address this issue and ensure food security, it is necessary to protect and expand agricultural area and provide irrigation in sustainable manner. Limited research that have been focused in Sugar province in my research area. There is unplanned settlement which is lead to loss of fertile agricultural land. This study aims to fill research gap by identifying the land suitable for agriculture, surface irrigation and lift irrigation. This is my study area. For this research, I collected many data from different institutions. This is the flowchart methodology adopted for this study. For this, first of all, I prepared the elevation map, slope map, soil depth map, soil texture map, soil pH map, organic carbon content map, and land cover map. Then I did image classification using GIS software. Then I determined the weight of different parameter using ASP technique. Then I performed weighted overlay analysis in GIS to prepare final land suitability map for agriculture. In similar manner, for surface irrigation land suitability analysis, one another parameter is considered, which is proximity to river if there is water source. In addition to agricultural land suitability, other parameter and methodology is same as I already explained. For surface irrigation land suitability, for lift irrigation land suitability analysis, first of all I determined the perennial river network. Then I identified the every pumping point these are the result of my study. Agricultural land suitability map so that about 18.73% of the land is suitable for agriculture, about 12% of the land is suitable for surface irrigation, and 8.44% of the land is suitable for lift irrigation. I performed another one analysis which identified that how much the land is only suitable for lift irrigation, not suitable for surface irrigation. This analysis shows that give information about this. Thank you.
Thank you.
Okay, now I request Dr. Rama Mohan Pokhrel for further conduction.
Good afternoon, and thank you for everyone for yeah. It's me, Roshan Devpane, and my poster presentation is heat slope failure analysis, a case study of subsequent landslide located in Kathmandu province, Nepal. And here I have visited while I am doing mapping in Shivalik section, and the landslide is quite interesting. So I do some research in the landslide. The key objective of this research is to identify and analyze the key triggering factor responsible for the subsequent landslide. This is the photograph of subsequent landslide. The photograph taken from the crown of subsequent landslide facing southeast. That captures the initiation zone with deep crack and lateritic soil, highlighting the area where rainfall infiltration intensify hydrostatic pressure and trigger the slope instability. And the next one is the photograph photograph taken from two of the subsequent landslide facing north, showing main body of the landslide, and the drainage seen here is the down collar. And here is the sketch of the landslide, and some geotechnical parameters are studied from the soil samples. And this is the XRD that I have done from the soil samples, and it is the Casagrande plasticity charts of soil sample. And and I have concluded that the major factor is two major tectonic thrust, that is CCT and MBT. And from the soil test, I have obtained here one for benzoquinone, an organic compound, and a clay mineral quantum morillonite that also triggers the.
Thank you. The next presenter is Harold Thomas. Maybe you had two presentations.
Good afternoon, everyone. On behalf of my students, I am going to present the postal. And first postal is assessing geothermometer suitability in site of garnet clinopyroxene thermometer from Himalaya. As you know very well that this pair is very important to calculate geothermometer. Especially if you will observe the garnet CPX pair from Himalaya helps understanding high pressure metamorphism and tectometamorphic evolution of the region, and typically found in eclogites, high pressure gambrites and mafic garnet bearing niches. And I have collected data from Himalayan areas from various authors and processed through the software which I have developed in long back, and I have found especially if you will, I have compared all models, and Ganguly 1979 are the best model based on the regression analysis. And if you have a data, especially for the temperature, and if you will plot the temperature with 1 by Allen Keddy, so easily you can find the regression analysis, and regression analysis is close to 1. And on the basis of that, I have suggested that these models are best for applicable for garnet orthopyroxene pairs thermometer based on other models. The clinopyroxene zoning is also play a very important role. So always we have to be careful because there is a marvelous parameter based on subregular solution model. So for garnet, always you have to take, if there is a zoning, then always you have to take the ring profile with the clinopyroxenes of rim. Both must be in domain equilibrium, and then only you can get a appropriate thermometers. Thank you very much.
Can we take the next parts as well?
Yes. Second poster is geochemistry and pathogenesis of toronite, tontonite, granodiorite, niches of Babina area, district Jhansi, Uttar Pradesh. And you can see all these basically these tonalytic knives based on the Harker diagrams. If MgO, FeO, and CO and P2O and PiO2 with progressive increase in SiO2 and mainly in PTG, and calcium decrease content with slowly increase of sodium and Al2O3 increase in silica content. As you know very well, if tonalytic niche is fractionated, then only we can reach towards the more potassic granite eruption. And all this system is formed, if you see basically the different plots, so they focus especially in tonalytic niches, especially in tonalites section, and I have compared with already published data with like Singh et al. 2019 and Joshi et al. 2016 and Singh 2017 and present study. The black one is present studies, all lying in same field, in tonalytic fields, and here if you see the composition basis, so they are hornblende garnet CPX assemblages or CPX hornblende biotech assemblages, and mainly all these are derived from the partial melting of low potassic mafic rocks. Thank you very much.
Thank you very much. And if audience wants to you can ask more details with the responding authors. Thank you very much.
Okay, our presentation related to poster is over now. So I request again to participant to visit with the presenters if you are more interested outside. And presenters, I request to be with your poster after the launch. And participants and other researchers may query with you for the questions, and you will give the answer over there. Thank you. Thank you very much.
And Rahman Pokhar for the evaluation of posters, and I hope to get your evaluation at the end of the technical session.